Hi everyone, and welcome in the AWS Theater today. Now we're going to talk about NetApp and how NetApp can enable automotive and manufacturing companies to build very mission-critical applications on AWS. Hi, my name is Tilman Schröder. I'm CTO for automotive and manufacturing at NetApp, and there within this role, I work very closely together with the AWS ecosystem in building industry-specific solutions. So, as I said, main purpose of today's session is going to show you how we are supporting our automotive and manufacturing customers with their data management challenges of both today and tomorrow. So, before we start, a little bit of context, right? So we see this evolution of the cloud. The cloud has started to be just another web hosting experience, and you dump some photos inside the cloud in order to store something. But I think now, more and more mission-critical applications, such as SAP applications, PLM, digital twins, and all the things that we hear about today are more and more being onboarded to the cloud. And for this purpose, it's even more important to think about a very holistic design architecture and how to make those architectures as robust and as efficient as possible. So this is going to be the scope of today's session, and we're going to be very precise in showcasing you very specific use cases and customer examples and talk about very specific workloads, how we enable innovation on AWS together, whether it's just in the cloud or in hybrid architectures. Yeah. To kick it off, we're going to talk about two different trends, first of all, to give you some kind of context and scope of what we're going to talk about, and two kind of observations that we currently see. Number one, more and more product and engineering workloads are being migrated to the cloud. What do we mean by product and engineering workloads? Those are computer-aided design workloads, computer-aided engineering simulations, engineering VDI stations, or large PLM product lifecycle management systems. And on the right-hand side, you see from a survey that has been conducted recently that more than 80% of key decision makers have already or are considering migrating their mission-critical applications in the product and engineering space currently to AWS. So more than 80%, right? So everybody's talking about it. And why is that the case? Because of the core value proposition of the cloud, right? Because what the cloud offers is basically speed, flexibility, and performance. Take the context of CAE simulations, right? Rather than just procuring every few months the latest technology, you can be very agile and flexible and just consume it like this in the cloud. So that makes especially HPC simulation jobs running in the cloud more and more suitable, especially for the users who are actually doing stuff and working on it. So this is number one, a very big trend that we currently see. The number two trend that we currently see is that the cloud is massively growing, but also on-prem is here to stay. This is a very bold statement here on AWS, but I think we are also very aligned with AWS with regards to this messaging. So what does it mean is that especially in industrial manufacturing, the future is never going to be just one solution, either on-prem or the cloud. It's going to be like a symbiosis of both, right? It's going to be hybrid architectures that emerge depending on the different business needs. For example, the cloud, as I mentioned, offers scalability, flexibility, latest technology and performance, whereas on-premises environments provide the necessary data sovereignty aspects or the low latency that you need in order to run those kind of simulation workloads on premises. So our statement is basically that, and here you can see it from the Economist article a few months back, some kind of data points, that the cloud is massively growing, but on-premises is also slightly growing and here to stay. Because it's not that just workloads going to emerge to the cloud, but that more workloads are going to rise up, be deployed in the cloud, and for some workloads, on-prem is here to stay and necessary because you want to also have the low latency aspect and data sovereignty. So within NetApp, we stand for the hybrid cloud. And this is also how we're going to enable this. So our service or our underlying technology is basically Amazon FSx for NetApp ONTAP. And this is a very unique service because it's not yet another marketplace offering that you might hear a lot about from other people that you can order via the marketplace. We are natively embedded into the AWS console. So we are co-developing with AWS when it comes to file storage and data management layer that can be hybrid in nature. So expanding the on-prem legacy onto the cloud. And what we offer there, as said, is a very high-performance file system that can be just directly provisioned via the AWS console, and that you can, for example, use in order to use multi-protocol capabilities, advanced tiering capabilities, and all these kind of things to make a very robust storage and data management layer underneath for your most mission-critical applications. And since we are here at Hannover Messe, we also wanted to showcase you very specific examples how our technology enables the most mission-critical applications that have something to do with automotive and manufacturing customers. And this in the domain, again, of product and engineering workloads. We've identified product and engineering workloads, right, as CAE simulation workloads, product lifecycle management systems, or engineering VDI stations, but also for new emerging GenAI workloads that come up. And our value proposition in a nutshell, what we can offer here, and together with AWS, we either have customers who validate those numbers, or we did the case studies on what we can actually achieve. For example, when it comes to product and engineering, we can accelerate simulation times by up to 30%. This is massive because, right, we can reduce the overall time that it takes to actually run simulations by 30%, which directly translates back into higher productivity that you can achieve. You can run more simulations in the cloud with our technology than you can with other technologies, which directly also translates to a higher degree of innovation capabilities. Second, you can significantly reduce your resource infrastructure costs, right? So because we have advanced tiering mechanisms, you can tier down all the cold data and just use the performance tier for the most efficient data that's needed. And by those means, you can significantly reduce your overall cloud storage costs associated to this, reducing in a higher total cost of ownership for your mission-critical service applications. And then also what we then do is we actually automate and can automate different processes associated to those mission-critical applications to run just automatically. And this translates back that we can, for example, instead of synchronizing data back and forth and taking 8 hours just to wait for the data to be synchronized from one point to another point, what we can actually do is we can automate these processes and just get it done in 4 minutes instead of 8 hours and have tremendous efficiency gains by means of those. And in the following, we're going to dive deep into those 3 different workloads that I touched about and really dive deep into the value proposition and how we create value in those domains. So, workload number 1, product lifecycle management systems. Those are basically the systems that are currently migrated to the cloud, such as Siemens Teamcenter, Dassault 3D Experience, or PTC Windchill. Those track all the different components, right, from the sourcing up to the after sales of the different components and help all the manufacturing companies to get a holistic overview around the different component landscape. As mentioned in the introduction, we see this massive shift of those kind of workloads being migrated to the cloud. What we provide is basically, if you add us into the storage tier of those kind of capabilities, you basically get rid of the number 1 challenge that most customers have. If they want to migrate their mission-critical PLM applications to the cloud, sometimes they experience a decline in user experience, meaning that it suddenly takes longer, right, to wait for the files to open and these kind of things. By integrating NetApp FSx for NetApp ONTAP into this service architecture design, we actually accelerate those data access times, keeping the engineers who work on the PLM systems more productive. Further, based on or well aligned with the well-architectured framework on AWS, we also provide the necessary business continuity aspects when you want to migrate a PLM system to the cloud and reduce the overall recovery point objective or recovery time objective to the optimum, that you have a very much guarantee for business continuity when you migrate your mission-critical PLM system from an on-prem premises location to AWS. This is workload number 1 and how we create significant value by adding our storage into these kind of service architectures by reducing for time, efficiency, productivity, and costs. Workload number 2. This is around CAE simulation. And this is an example that I brought based on Rivian, who is one of our largest customers based on FSx for NetApp ONTAP, using our technology for their large-scale mission-critical simulation platform that they host on AWS today. If you think about the simulation workflow, you think about different processes steps, right? So you need to take care of different processes steps and translate it to the IT world. You need to have different clients actually accessing the file system based on Windows, Linux, or based on these 2 machines, right? So you either have the client side or actually the machine who is running the simulation. And what we provide is we provide a consolidated storage system that basically can provide multi-protocol capabilities that makes the access to those files from one standardized storage instead of having multiple different storage systems. The effect is that you consolidate multiple storage systems into one file system and have a lot of redundancies moved away, and makes the overall management easier. The second thing that it also provides is, and this is the overall architecture, how we integrate, right? You see the green icon, this is our technology that we provide based on an overall HPC cluster. This is the example of parallel cluster. And what we basically provide is we accelerate the simulation times by 30%. By getting rid of the time that it takes to transfer the data to the HPC cluster that you see here. So we don't need to transfer the data, synchronize it, that oftentimes takes 30% of the overall process. We can just replicate the data there instantaneously and reduce the overall simulation cycle by 30%, which then translates back into significantly productivity gains, right? Because you can simulate the data flows way easier. And today I'm very happy because I ran into Thomas and we do a little bit spontaneous things here. So I'm also happy to have Thomas here. Maybe you want to join me on stage. Thomas is part of one of our key partners, Storm Reply. Exactly. And maybe you want to quickly introduce yourself and talk a little bit about how FSX for NetApp ONTAP actually helps you and your customers to provide those mission-critical simulation platforms.
Yeah, of course. Hi, I'm Thomas Heinen. I'm an AWS brand ambassador and I'm working for Reply. We are one of the big premier partners doing consulting on AWS, but we are also one of the preferred partners of NetApp. And in our projects, which often involve migrations and also HPC solutions, we are implementing basically the architecture which still provides, where we have a central storage by FSXN and then the different clients accessing it. And this isn't simply limited to CAE designs, but it's general a blueprint which you can use for HPC workloads in general. Because in this case we have a customer in the health and life science area who are doing exactly the same. They're storing big data on the FSXN file system, and then they are using this to use their Windows-based analysis software as well as on-demand scaling a parallel cluster, which can get really, really big to do simulation workloads on classical stuff like protein folding or genomic sequencing. So with this solution, you really have a good blueprint which can cover a lot of these different use cases. It's not really limited. And as I said, we have the experience, we can attest that it's really working well, and the customers are very satisfied that this works out of the box.
Thank you, Thomas. Thank you so much for just validating, right? That I'm not just making things up here and just talking about it. But yeah, as you can see, in a nutshell, integrating FSXN into those large-scale mission-critical CAE simulation platforms actually reduces the overall time that it takes to simulate, and also directly, and indirectly, has a positive impact on the overall cost structure and total cost of ownership. And yeah, this is just another slide, right? Just an example from the case study that I showed in the beginning. So it used to cost around 2 million to host this 4 million to host this HPC simulation platform on AWS with other technologies. And as soon as they integrated FSX for NetApp ONTAP into the overall service architecture stack, they were able to reduce it by 50%, making it just 2 million in order for overall infrastructure costs, and at the same time increase the overall performance. So net positive for all the parties, and yeah, low-hanging fruit to integrate into your service architecture designs. Workload number 3, this is the last one. So this is around cloud bursting. I talked about the trend of hybrid cloud in the beginning, right? So oftentimes GenAI and these kind of things are all happening in the cloud. You have the access to the GPUs, procurement cycles are long. So you want to leverage the cloud and also have the access to the latest tools, not just the GPUs via the cloud. But oftentimes your enterprise data, CAD files, whatever kind of data structure resides on premises. And now it's tough, right? How to make the bridge from actually those on-prem data sets to the cloud and benefit from both, right? At the same time, the low latency data sovereignty aspects from on-premises, while also benefiting from the innovative performance aspect from the cloud and GPU access and access to the latest models. So what we provide within our FSX for NetApp ONTAP storage platform, we have a feature called FlexCache, a caching mechanism that enables cloud bursting mechanisms, which basically means that you have a bi-directional relationship with your on-premises storage system where you have all the enterprise data residing, and the cloud basically in AWS, and you have a bidirectional relationship, meaning that you can easily cache only the data volumes that you actually need, or the positioning of the data, to the cloud, run the GPUs on top of it, and then cache the data back to the source where it is to be data compliant, for example, or to reduce egress costs, because you don't need to push all the data, just the chunks that you really need to the cloud in order to let the GPUs work on it. So this is another very interesting workload that we currently see very much adapted by automotive and manufacturing customers when they want to build a bridge between on-premises systems and the cloud and balance resources most efficiently across those two environments. And this is just another example because we have many customers using this technology as of today. This is not like an R&D effort. For example, here you have ARM. Many customers from the EDA and chip design space are using exactly this technology to burst to the cloud for such peak in demands and use the latest GPU access, push the data there, run the GPUs on top of the on the cloud, and then later on push the results back in order to have it securely stored on premises again. So a really great use case to show you how we can actually enable true hybrid cloud experiences. And yeah, this is a great customer case study. So to conclude, right, we just showcased you the different workloads and what we can provide in AWS. We have computer-aided engineering simulations. We talked about PLM and product lifecycle management systems such as Siemens Teamcenter, Dassault and PTC Windchill. And we talked about the generative AI aspect of cloud bursting, right, and bursting the data to the cloud to actually do some stuff there. And overall, you see that FSx for NetApp ONTAP, or NetApp as the data platform to build those hybrid cloud environments, is truly a good choice in order to accelerate simulation times and reduce total cost of ownership, which are kind of like the key matrices that you want to optimize for when you move to the cloud and provision those kind of mission critical applications. We showed case studies, right? We have many customers doing it already, and we are very much eager to collaborate together with you in order to provision same architectures or help you innovate in the hybrid cloud space and build those bridges between on-premises and cloud, or just exclusively on AWS and making those overall architectures more robust, more efficient, and more secure. Yeah, please feel free to reach out to us via LinkedIn. Here's the name. I also need to make some kind of advertisement for our booth. We are directly behind this theater where we currently have a raffle at 4:30. You can win a Porsche. Not a real Porsche, but like a Lego Porsche. So really nice thing. I think you can also win a Nintendo Switch if you participate. So please feel free to come by to the booth, take part, and maybe you are the lucky winner. And then after you win the Porsche, we can innovate in the cloud or in the hybrid cloud, whatever suits you well. Cool. Yeah. Thank you very much. Thanks again to Thomas.